All right, everybody. Today we're going to be talking about finding the volume of an irregular prism, such as this pool-shaped object in front of us. Now, first thing I want to talk about is that whenever I'm doing a volume calculation, I really think about it like a surface area calculation with one extra step. And so I'm highlighting here sort of this two-dimensional front face. And then once we find the surface area of that, I'm going to think about ultimately then multiplying it through a third dimension. That's really all the volume formula does. But we can't find the surface area of this shape in the front because I don't have a volume formula for, or a surface area formula for that thing. In fact, I don't really even know what to call that shape. So it's going to be useful to break it up into some pieces. I want to slice this thing vertically at the locations where we have a slope change on the bottom. So right here at 15 feet, I'm going to say that that marks sort of our first trapezoid. It's got a front face here in the red, and then we'll ultimately be multiplying it back through here. Then we've got our middle portion, which I'll outline in blue here. It shares the same left edge and comes all the way over to where our slope change is at 5.5 feet. And we're going to be multiplying that, again, ultimately back through that third dimension to find the volume. Our final piece is this rightmost portion. It shares a boundary again at 5.5 and comes all the way over to a shallow depth of 2.5 feet. So these front faces are trapezoids, which we really can basically treat like rectangles with one simple trick. So the volume formula for a trapezoid is base 1 plus base 2 divided by 2, which is really just the average of the two bases. So we're basically saying, okay, the shape's got, uneven sides. We really like if they were even, and so we're just going to find the average of the two. Then we can basically treat this like a rectangle and multiply that number by the height, which technically is the perpendicular distance between the two bases. And then at the very end, sort of as our last step, we're going to multiply that by the depth. So ultimately, when we're done with this, our volume total is just going to be V1 plus V2 plus V3. We're just going to go through and find the volume of each one of those trapezoidal prisms separately, and then we're going to add them all up. So, again, so for V1, we've got, I'll do a little diagram here. Got 11 feet on this side, 15 feet on this side. We've got a width of 20 feet. And then we ultimately do have that depth of 60 feet. So when we calculate the volume, we're going to take our two irregular, different sides or different bases, and we're going to average them out. 11 plus 15 divided by 2. Then we're going to take that number and multiply it by the height and the depth. So our average base length is 13. It's 26 divided by 2. Multiply that by 20 and multiply that by 60. 13 times 20 is 260. And the reason why I calculated that separately is just to illustrate a point, which is that 260 number is the surface area in feet squared of that face. And now for the volume, we're going to take that and multiply it through this third dimension here. Take that 260 number, multiply it by 60 for a volume. Sorry. Being left-handed is not always useful with this software. We get a volume of 15,600. And now we're just going to repeat that process for the other two sides. This other two, this volume 2. So call that volume 1. Volume 2 has that 15 feet side on its left now, and it slopes up to a shallower depth of 5.5 feet. Now, it's unclear what the width is at first until we see that we know the total and we know the other two pieces. If we know that this distance from here to here is 20 feet, and we know from here all the way to here is 70 at the bottom there, well, then the leftover portion is just the total, 120, minus those other two pieces that we do know, minus 70, minus 20, which does give us a width of 30 feet. So this is going to be 30 feet here. Again, multiplied back through by that same depth of 60 feet. So for V2, again, we're going to find that average of our two bases, 15.5, 15 plus 5.5 divided by 2 times 30 times 60. So 15 plus 5.5 is 20.5, divided by 2 is 10.25. We're going to multiply that by 30 times 60. Again, just to kind of illustrate that surface area point, if I multiply our first two numbers together, that's our surface area number for that actual face. And then we're taking that number and multiplying it through a depth of 60 feet for a volume on that piece of 18,450 cubic feet. And then finally, got our last side here. Shares that 5.5 foot edge and then slopes over a long length of 70 feet up to that shallow edge of 2.5 feet. So going back through 60 feet, we have everything set up that we need for our last calculation here. Our volume is going to be the average of our bases, 5.5 plus 2.5 divided by 2 times the width or the height, kind of interchangeable there, times the depth of 60. 5.5 plus 2.5 is 8, divided by 2 is 4. If we multiply those first two numbers together, we see we get a surface area of that one of 280 times 60. And then we can multiply those two together for a final volume of 16,800 feet squared. Or, sorry, cubic feet. So the total in the end is 15,600 plus 18,450 plus 16,800, which is 50,850 cubic feet. Thanks for watching, and if you have any questions, just reach out.